Hey guys, this is the first video of 4 in the transformation section of this unit, and your group is only responsible for watching this first video. The other information you should get from the other groups. I will post all the videos and the notes though in case you missed something you need to go back. Alright, so we are going to talk about transformations, and your learning target is 4G. I can perform transformations of parent functions. So you should have learned all the parent functions last time, and you can always use that reference sheet to look at what they are. Within transformations, there are multiple different movements that we can do. And you might remember this from geometry. There were reflections, there were translations, there were dilations, and rotations. We're going to do the same thing, but we're doing it with functions instead of with shapes. So our first one is going to be a translation, and we're going to focus specifically on a vertical shift. All right, a different group is going to focus on a horizontal shift. So all of these different rules apply to any of the parent functions that we work with. So that's really important. It doesn't matter what function you're talking about, the rules are the same, and that's really nice and helpful. So to start, all functions are based on parent functions like we explored last time. All right, so it might be the quadratic, and remember your parent functions are just the most basic form. So they're centered around 0, 0. If they had a slope, it's the simplest slope. There's no stretching or shrinking or moving left and right happening. We're going to do that now with the transformations. So they're based on the parent functions. Starting with the parent function, we can perform transformations to change the function. So that's what we're going to be doing. We're going to take that parent function, and from that, I like to think of that as the mama and the papa function. From that, you can make all the little baby functions, which are just little bitty changes to the original function. So they all are going to look really similar to the parent function, but they'll be in a different place on the graph, or they might be stretched in a different way. The one we're going to focus on is called a translation. All right, and translation really just means a slide. So you might remember that from geometry when you were moving graphs to the left and the right, sometimes, or up and down. You might see some notation like this. If we wanted to move it up 3 spaces, this would really be saying take the y and add 3 to it. So if you remember that from geometry, that's potentially one of the things that we could see. We won't use this notation much with functions because we're going to be doing it to the equation, not just the individual points, but still works the same. Underneath translations, there are 2 types. The first being a vertical shift. All right, that's what we're going to focus on here. This causes the parent function to move up or down. So vertical shift, vertical being that direction, you're just sliding that parent function up or down from where it originally started. And if you think about moving up or down, what we're really changing is the y value. All right, we're going to do this by adding or subtracting a number to the end of the function. So the placement of the number is the most important part when we're talking about these equations. So we're going to have whatever our function is, and I just wrote f of x because could be quadratic, absolute value, square root, rational, all the parent functions we looked at. And then we're going to take whatever that function is, and we'll just add on a number, and I'm using d to represent that number to the end. If it's positive, the graph moves up. If it's negative, it moves down. All right. So let's try a couple and see what we come up with. So we're going to start by thinking about the quadratic function. All right, so what equation is the parent function of the quadratic? F of x is equal to x squared, right? So this is our f of x, right? That's what that function is. And this first one is asking me to move the function up 6 spaces. So I would do that by adding 6 to the end of the equation because we're moving it up 6. So f of x plus 6 is one way to write that. But if we know f of x is equal to x squared, we can get a little more specific. So we could write x squared plus 6, and we would see our graph actually shift up 6 spaces. So let me see if I can, oops, can I do this while I'm recording? Oh, look at that. So if I type in x squared to Desmos, we see, this parabola shape centered at 0. If I type in x squared plus 6, notice I don't really need the f of x there. Desmos knows what I'm trying to do. We see that we have the same graph. It's just shifted up 6 spaces, right? So that's what we're really doing there to move that function. Same shape, same size, just moved it up. So what if we want to move it down 2.5 spaces? Well, we could do f of x minus 2.5, or since we know what f of x is, we can write it as x squared, which is our function, minus 2.5, right? So if I did x squared minus 2.5, look right there, same shape, same size, it's just been shifted down 2.5 spaces, all right? So next, let's try the absolute value function. So think about what is that equation that makes the absolute value parent function? Well, it's just absolute value symbols around x, right? So this says move the function up 29 spaces. So we could do f of x plus 29 if we want to be general about it, or more specifically, absolute value of x, so there's my function, plus 29, right? Again, you could check that on Desmos if you want to. So functions, miscellaneous, are they going to give me an absolute value? Oh, there it is. So absolute value of x looks just like that, right? And then if I want to do absolute value of x plus 29, well, there you go. I added to the end after the symbol is closed, and I shifted it up 29 spaces. All right. And then lastly, let's take a look at the square root function. So remember your square root function, the parent function is the square root of x. And this is asking me to move that down half a space. All right. So then we would do f of x is equal to the square root of x after the symbol ends minus 1/2. So the function is enclosed by the symbol or the exponent. So after the exponent, like up here where we had x squared, that's when you want to add or subtract your number. Or after the symbol closes, that's where you want to add and subtract your number. Okay, that will move it.